All right, I want to look at some plotting, and what I'm going to do is a couple different types of plots. Now, plotting with this utility opens up a separate window, so I want to come back, which means I might have to switch back and forth a couple times to show the results. I want to clear all of this here, and I'm going to go with some of the basic plots in the book, and then we'll add to what we can do with the plots themselves. So, plotting uses lists. And so a lot of times we'll get a list of values. So if I want to plot my x values, I can use a lin space or a linear space that will go from 0 to 2 pi. And I'm going to have 50 pieces. So that's one. If I look at x, if I run this and look at x, this will show all of the values of x. Go back here and run chapter 2, or chapter 1, section 3. And so notice it has created 50 values of x that are evenly spaced between 0 and 2 pi. And what I can do is I can push every one of these values through the sine function. So I'll say y equals the sine of x. And so this is going to pass the whole list or the whole vector into sine of x. And so functions in Octave and MATLAB work on vectors and functions. This will give us some issues when we have to process everything element by element, but what sine's going to do is spit out an answer. And we'll look at it again here. I'll do file, save, whoops, not save as, file, save. Okay, it has been saved. Come back here and rerun this. And now I get the output of the sine function, and I have 50 answers to sine, starting at 0, rising up. I don't quite get to 1 because of how I did my divisions here. And then back down to negative, not quite near 1, and ending back at 0. So I actually have two lists now. I have a list in y and a list in x of sine values. So the first way I want to plot this is I want to say scatter. And I want to plot x comma y as a collection of points. And this might be a little too big, but we'll run it here. And so let's see here, you have the output here, but I've got to switch over and change the window I'm looking at. Give me a second here. Is it showing up? Octave window. I'm going to try to switch my windowing source here, and let me click on this. Nope. There we go. There's the figure that pops out of Octave. It pops out a separate window, and this is called figure 1. And we can actually, because I did scatter plot, it's plotting all of those 50 pieces. I can have some tools up top with this. I have a move tool, so I can move through the plot. I can zoom in and out. I can add grid lines. I can control if the axes show or not. Those are things we can also do within our function. I can zoom in and out, and I can rotate the axes, which work really nicely with 3D vectors. And I can also save this. And in my case, I'm going to save it as a ping file. PNG. I have a JPEG and a ping. And so I'm going to call this a scatter sign. And so now I have in my directory structure a PNG file. And what will happen is Octave will keep refreshing this as I change other things. So I'm going to go back into my editor here. So I'm back into Octave. Now I made it large because I was making the figure show up. I apologize for that. I told you there'd be a little bit of problem because it opens the new window. Let me size things appropriately. Hopefully not making you too dizzy here. There we go. And in my editor, I'm going to change scatter to plot. So, and change this to plot. I'm going to put a comment. % comments things out, and Octave won't run things that are in %signs. And I'm going to do a plot XY. And plot XY tries to keep straight lines, or it connects all of the points with straight lines. So I'm going to file save this. I'm going to run it. Now if I run this and I have minimized my window, I don't see that the figure has updated. But I'm going to move over here and I'm going to switch to the figure again. And there we have now a smooth sine curve. And so this is the utility we're going to be using to make graphs and different things we can do with the graphs. I'm going to go back into my code again. And I'm going to show some things about figures in general. So in my code, I had 50 things in the sine curve. Let's take it down to just 10 points. So I use 10 points in my sine curve instead of 50. And if I go look at the figure now, it got all choppy in lines because it's playing connect the dots. And so the more dots we give it, the smoother the figure will be. And that'll be part of what we need to do with our figures. All right, there's a whole bunch of things we can do to make our graphs look nicer. I'm going to try to put them together. I'm going to come back here and I'm going to show something that we can do with scatter. I'm going to make a new set of objects. I'm going to make some points. I want to make x1 be the x values of a coordinate pair. And so 0, 0, or 0 is one I know. I also know that, let's see, square root 2 divided by 2 is 1. And I know, or wait, my x value is actually pi divided by 4, pi divided by 2, 3 times pi divided by 4, pi. So we'll do the first upper part of a unit circle, and I know the y values for those parts of the unit circle are 0, square root 2 divided by 2, 1, and square root 2 divided by 2, and back to 0. So I have y values and x values that are in point pairs. So this 0 matches this point, this pi over 4 matches square root of 2 over 2, and so we have pairs. What I want to do is I'm going to add an additional command called hold on, and I'm going to add a command hold off when we're done. And what hold on does is it freezes what's on the graph. So I'm going to save this file, and hopefully I haven't made a typo. I do make typos occasionally. Oh, I called it Y2. I should have called it Y1. So that's what a typo looks like. So I'm going to save this. And when I run it, it's updated my graph. So I'm going to come back over here, and I'm going to look at my updated graph. Notice that the points that I defined are dotted on the graph. I have little dots from the scatter plot over top of my graph. And so if I'm matching towards data values, I can plot the curve and the data points together. And so that's a useful thing. The hold feature and using a scatter plot works on that. Let's go back here. I'm going to do a couple fixings to this. I'm going to smooth out my graph. So to smooth it out, I'm going to go back to using 50 pieces here. And then we're going to have some options. So I'm going to want a grid. And I'm going to label my axes. So X label. I'm going to put X on the X-axis. Y label on the Y-axis. You'll find, if any of you have worked with Python, Python's matplotlib is based off of the Octave and the MATLAB graphing system, and so a lot of these commands also show up in the Python matplotlib library. And we'll call this a sign graph. Put semicolons and everything here. And we'll give it a legend. No, I won't do a legend yet. I want to change my color here. So with my scatter plot, I can change the type of dots and the color. Let's see, where's my scatter plot? I think I'm going to use plus signs. Whoops, where did I? Control Z. I'm going to make these blue and a plus sign. I think that's the order. We'll try it. If it doesn't work, we'll catch the error and we'll move from there. So it didn't give me an error, but we'll see if I got what I wanted. When I move over to my figure, I'm going to make my figure a little larger. I've still got circles, and notice my hold on has made my graph go through. So what I'm going to do is I'm going to close this, because the hold is holding everything I've done before, and I'm going to rerun it. One of the things when you start using hold is it doesn't clear what's on your graph, and so you have to come back to it. And so notice this is what my script runs now, is I have plus signs on my scatter plot points, and I made the scatter plot blue. And let me fit my screen back on the window here. It's funny, if I just do a little bit of a change to the figure size, it dramatically changes the size of my Octave editor. Like, much more than I expected it to. So this is when, for your comp sci majors, watch your matrices multiplications, because that's what's scaling my things. Here are some different matrices scalars, and they're not translating between the two screens here. All right, so, and I think I'm going to change the color, since they're both blue. I'm going to change the color of the sign graph. So I'm going to make the sign come out. I'm going to make the color for that a green. We'll use and so now when I run this, again, if I come back here and pull up my figure, I have blue plus signs for my data points and a green graph. It's labeled sign graph. I have grid lines on it, and the X and Y axis are labeled. So we actually really quickly, without much work, get the ability to start graphing functions and graphing different things. All right, that's going to be the introduction for graphing from me here at least. Let me get back to the right utility. You have enough stuff that you can start attacking your homework problems and using Octave appropriately for it, especially for the graphs. And what we can do is I strongly recommend looking at the first chapter in the introduction to GNU Octave, especially section 4 on plotting. There are a lot of options on plotting that I want you to play with. I strongly recommend playing with the exercises at the end of the chapter just to see if you're comfortable with it. but it's not something I'm going to require. I will require in your homeworks to have plots and graphs and proper use of Octave material, but I do not. I'm not going to require you to go through the book coming through. We'll use the utility and get the most we can out of the utility. And I will continue. We'll really start digging into Chapter 2, Matrices and Linear Systems. You should already have started to see reduced row reference. Left division is an option I haven't shown yet. And later on, we'll start doing LU decomposition and QR decompositions, which we will have ways of working with in there. If you really want a hint for the homework, in Chapter 1, I do talk about polynomial curve fitting, and 2.2 in this book has this from a least squares form, which is where we're going to end at the end of Chapter 8. So you might want to look at some of the plotting things they do around there to play with it. But in the homework for Chapter 1 and 2, I have given a quick thing called polyfit, which lets you fit a polynomial, which is what we're doing right now. So most of what we'll be doing in this class with Octave fills in Chapter 2 of this Intro to Octave. We will do some things with eigenvalues and eigenvectors, which is a little further off. If you have any questions, continue dealing with me. Have a wonderful weekend. See you on Wednesday.